into the presentation mode. Yannis, is everything okay?
Yes, everything is okay.
Yeah, okay, thank you. And I just want to start with the content. And today I will just try to cover some aspect related with the applications and research of AI and machine learning in Turkey, mining specific, of course. So I will try to briefly introduce myself and then rapidly go into the current awareness adaptation of artificial intelligence and machine learning in Turkey, whether I just want to have a look at what can we do and we can't do with the machine learning or artificial intelligence right now. Then I will try to present the current applications of the machine learning or artificial intelligence in Turkey. These are really recent works because last week I have attended to IMSET, which is the one of the biggest congress related with the mining. And so, as you know, AI or machine learning is rapidly evolving. So I just want to be up to date as much as I can do. So we will look generally at the works related with mineral resource estimation, prospecting, in marble industry, and finally mineral processing. And then I have just added a few slides related with where can we go with the AI or machine learning. Mainly, I think deep sea mining and space mining will be realized by the use of these technologies. And as briefly introduced by the Yannis, I just graduated in 2008, and as already said, I'm from Hacettepe University, and all my PhD or Master of Science studies are based in Hacettepe University. Later, I just visited the University of Queensland at Australia in 2022, and this year I am promoted to the associate professor. And I just want to introduce my team because there are nearly 23 academics in Hacettepe University, and my core team consisting from 6 people. They are all have PhD degrees in mining engineers, and I am, and a few of my colleagues are from second generation of the team, and our first generation consisted from Professor Ünver, Bahtiyar Ünver, Abdullah Erhan Tercan, and Mehmet Ali Hindistan. They just took their PhDs from Nottingham University and Leeds University in England. And the second generation consists from me, Fırat, Süleyman Yasin Kıllıoğlu, Mehmet Supi, and we have a broad expertise area in rock mechanics, underground mining, open pit mining, mineral resource and reserve estimation. The overall experience of our team is more than 40 years, and we are industry-oriented team and trying to merge the industry with the academy. And we generally finished more than 65 projects until now with more than 30 companies. And we have international accreditations like the also IMM, IM3 England-based accreditation. And UMBREK is the Turkey equivalent to AUS IMM, which is located in Australia. And we have brought experience in many commodities like iron, polymetallic copper, gold, coal, magnesite, rare earth elements, antimony, and industrial raw materials, and etc. So I can say that we are the best team in Turkey related with the mine design and mineral resource estimation. So let's continue with the content that's current awareness and adaptation of AI and machine learning in Turkey. I just want to start with Daniel Kahneman. Unfortunately, he passed away in this year in 2025. He's, as you may know, Nobel Memorial Prize winner in economics in 2002. And I really like his ideas because as you know, artificial intelligence and machine learning is evolving every day. So we have some intuitive about that. But what he claims that don't trust your intuitive statistics. So I just want to merge this idea with the current awareness. So he even sometimes claimed that statisticians are not a good intuitive statistician. So whenever I talk about anything related with currently evolving, I just want to look the statistics in order to not get trapped in my intuitive. So I will present some data related with the current adaptation awareness of the machine learning or artificial intelligence in Turkey. Last night I take some Google Trends data. As you see, some parts are in Turkish because I just want to make a search in the Google Trends what's things are going on, what is the attention of the people in Turkey to the machine learning and artificial intelligence. As you see, blue line shows the search volume of the artificial intelligence. It is increasing by time. But there is a red line at the bottom of this graph. You'll see that machine learning, it is virtually nothing. Because what I think that most of the people are just trying to learn something about artificial intelligence, but not learning about what can they do with what can they produce with machine learning. Just they are trying to searching in general terms. So I think the current situation in Turkey is that most of the people are just using in daily life, just searching some terms in ChatGPT or Gemini, but not creating a product with them. What I'm seeing in my lectures given to the industry, that overlaps my analysis because in Turkey people are just discovering what is artificial intelligence, but not discovering what is machine learning. So I think we have too many opportunities in Turkey to integrate machine learning in our engineering life. There is unfortunately no specific data related with mining, but I can intuitively say that the same situation applies to mining specific. And I just want to go into the next subject that I want to cover because most of the people thinking that artificial intelligence is something like a magical stick. You can do everything with them, and just writing some bunch of codes will be enough for that. But to be on realistic sides, I just want to share, especially at my course industry, what can we do, what can we do with that, and what are the current capabilities. And as you see, self-driver cars are already in our life, even though there is no self-driving cars are allowed in Turkey, but I know that you can use in this self-driver's car in United States. So when you detect an object, you can use this technology because the main idea automation is that if a human being can decide one thing less than in seconds, it can be automated in near future or rapidly. So I'm sure that everyone in this lecture can find the cars easily less than 1 second. So we can use artificial intelligence in this problem. But what can we do that? I just want to ask the participants that what is the meaning of this for you? Yeah, there is only a finger just pointing somewhere. what might be the meaning of this? Yanis, I can see that you are talking with your students.
Yes, they say
What
that
is their
it's
response?
what we
Yeah,
do when we want to raise our hand to talk during a
talk.
lecture.
Yeah.
Yeah.
Anything else?
What else? Diálogo. Nada que explicar. An aeroplano, etc. Well, you already said that, to point towards an
Point.
object.
Yeah, point.
Yeah.
Okay. And
Diálogo?
yeah,
Something else? Number one?
number one. Yeah, it's good.
Just one?
Yeah, good. In even small number
Idea. Mhm.
of people, we have three distinct answers.
Mhm.
So in that case, artificial intelligence does not work properly. So when one gesture means one thing, artificial intelligence works well, but in such cases, because we are just interpreting the meaning as a human being, so in such cases, artificial intelligence is not very good. And I have another example for that. For example, this means stuff for me, and I think it is similar in Greece, probably. But in Arabic, that means you are welcome. So in that case, we cannot create a system that properly understands the meaning internationally. So it must be localized to work. But in human gestures, as far as we know, it is not working very well when one thing has more meaning more than two. And as already in this lecture knows very well, machine learning or artificial intelligence applications are data hungry. So, for example, say that, like in that case, if you want to diagnose a phenomena from an image, you have to 1,000 images of phenomena, and then you have to train your model. So it may capture very well that illness, but we cannot ask from artificial intelligence to read 10 books related with the concept and then try to estimate the illness just from the 10 image in this medical textbook. So it is not good in such a kind of things. When data is not available or limited, it works poorly. And to summarize these things, AI works well when learning a simple concept, like detecting a car, that I have given as an example, and when there are lots of data available. And it works poorly when small amount of data is available and it is asked to perform only types of data which has not trained on it. So it is really bad in extrapolation in current time. But there are some attempts to increase the performance of the machine learning algorithms in order to extrapolate. And one example that I want to share with you that, please forgive me because I couldn't find the source of this image. I'm not claiming the intellectual property of the figure, but AI works poorly when things get complicated. For example, in that case, every human being can guess that the most left figure is an Indian elephant, shows a part of an Indian elephant, and the middle figure shows a cat, and the rightmost figure, it is clear that mixture of these two figures for human beings, but again, AI works poorly. It thinks that it's an Indian elephant or something like that. So, as I said, when things get complicated, AI starts working poorly. So, most people which are not technical thinks that AI will replace human beings. But when I see the examples, I'm just laughing that kind of thoughts. And that is what I want to share about where AI works purely and good. And just right now, I just want to dive into the application and research of AI and machine learning in Turkey, mining specifics, of course. And most of the studies, presentation that I want to share with you will start with my works, because it seems like that I am the most famous and front runner in this area in Turkey. I have many meetings with the companies, and they are just asking me to create projects and give lectures to them. So my next 2 weeks, even full of with meetings. But I just want to be up to date. My works nearly goes 10 years back, but I just want to share with you my latest research, and which was about mineral resource estimation. And I just try to estimate the iron grades at an ore deposit using XGBoost algorithm, which is accepted the Mining Metallurgy and Exploration journal, which is located in the United States. And then after the acceptance of the full paper, they just invited my paper to the magazine, their magazine, SMA's magazine, which is distributed to all around. Nearly they have 13,000 members in worldwide. So I just shocked with that, because this work was not my best work, but it took attention of the committee. And what is the main problem with mineral resource estimation in current industrial level? We are just using, mostly we are using the kriging, and when kriging cannot be applied, we are just moving to other approach like inverse distance weighting, or sometimes even nearest neighborhoods. But in this study, I just want to apply the XGBoost algorithm. And I didn't go into technical details. I won't try to explain the XGBoost, because there are too many approaches. So 2 hours will not be enough to cover all of them in deep. But XGBoost is a kind of advanced implementation of gradient boosting algorithms. And just it is more efficient form of, can be considered as a most efficient, more efficient form of trees, which are very well known and belongs to machine learning family. And as you know, order encouraging has some problems. One of them is smoothing effect. I know that Yannis is teaching mineral resource and ore reserve estimations in your university, and at your university, and creating smooth, which means that a high grade value, estimated high grade values on the blocks are lower than the composite values, and the low grades are higher than the lowest value in composite values, which decreases the variance of a estimation. And there's a strong assumption in kriging, which is a stationarity assumption, that is the equivalent to homogeneous behavior of the deposits. And in complex geologies, we never see that kind of behavior. And also, it requires variogram modeling, which is complex, and you have to validate the variogram in order to use them appropriately, and it is time consuming. So in order to overcome some problems related with overcome, I just tried to XGBoost and just compared results with the kriging. And to introduce the problem or the ore deposit, I used an iron deposit located in Turkey. Due to the privacy, I cannot expose the location, but I just can say that it was an iron deposit. And I used composite values as an input. As you know very well, I think. In machine learning algorithm, you have an input and you have a target. And you just train these models from the training data by using the training data and to get the desired output. Then this trained model can be used to estimate the unsampled locations. So my input was the coordinates of the composite values, and the output was the iron grade. And I used XGBoost, and results were directly compared with ordinary kriging, which is industry standard in these days. And in XGBoost, you have to tune the hyperparameters, which are specific to approach. And the learning rates was tuned maximum depth of trees, subsample ratios, and number of estimators were tuned by using the grid search, which means that it is kind of use of brute force, just tried every possible combinations in the given discretizations to find the best parameters. And later results showed that estimation range, which means that minimum value and maximum value of the blocks estimators were higher than the kriging, which is desired property in any kind of estimation. And also the variance of the estimation results were higher than kriging, but when compared with the raw data, it's already showed a smoothing effect. And when we compare results of kriging with the XGBoost, the Pearson correlation was 0.63, which means that they have average relation with the kriging. And as written in here, the XGBoost created statistically desirable results than the kriging, but it still suffers from the smoothing, which means that variance of the estimations are lower than variance of the composite values. Unfortunately, it couldn't create the same statistics with like composite values. This is the same case in kriging. And to compare the methods better, I just created a table. In ordinary kriging, smoothing effect is higher compared to XGBoost. Range of estimation is wider. And you don't have to model the variogram like the case in ordinary kriging. But one thing is that I think the problem with any kind of machine learning approach, the modeling approach is implicit. It learns from coordinates, but you cannot explain the results. There are some attempts to increase the explainability of model, but I think they are just not enough to explain physical relations. And in geostatistics or ordinary kriging, you have to have a good geological expertise in the area. But in XGBoost, you have to just optimize your hyperparameters. So the main idea behind, as you know very well, machine learning algorithms just learn from the data, so you don't have to have geological expertise for this case. And my final results is that it can be used alternatively to kriging. As you see in here, but I don't want to read all of them. But it successfully mitigated the smoothing effect compared with kriging. The results or statistical results of the estimates were closer to the composites compared to kriging. It implicitly captured the great continuity. So I think it's a good alternative to classical maths. My first case study was that I want to share with you. The other my work related with the mineral resource estimation, which is in Turkish. So I just had to translate some parts in English. There is a contradictory results in the use of machine learning algorithms. Some people or geostatisticians reports that classical geostatistical techniques are better than machine learning. And some academicians thinks that it is just an alternative to the classical geostatistical techniques. And other statisticians thinks that machine learning is superior to geostatistical methods. This debate still continues. I just want to make an addendum to these discussions, and I just wondered whether which approach is creating better results. So I just tried mainly 3 techniques, but I selected these techniques because I think that these 3 techniques are working better than the other machine learning algorithms. So one of them was random forest, other was XGBoost, and the other was artificial neural networks. I just compared these techniques with classical kriging. And I think everyone knows the limitations of the kriging very well in this room. And also machine learning approaches are not free from the limitations, like they are black boxes. So your explainability of your models are real low. You can understand why it produced the given results. And sometimes it is really easy to overfit the hyperparameters, which means that it learns very well your training data, but its generalization capability may be less. So compared to training data, so it works poorly on unseen data. And other limitation of the all machine learning approaches in today's world are they require massive amount of data, but generally this massive amount of data is not available, especially in early stage of the exploration or mineral resource estimation. And it's computationally expensive and hard to interpret the model. But they have some strengths, like machine learning algorithms can sometimes, if they have data, they can sometimes capture the complexity, high complexity is. Their predictive accuracy may be high, and they are very good in capturing the nonlinear relationship between the inputs and outputs. And general workflow of the study was that very similar to first example. I just started with the coordinates of the composite values, then later tune the parameters by using again the grid search. And as you know, these parameters should be validated with the test or validation data. Sorry. And then if it performs on good on test data, which means that it can be used for estimation, then using this model, block model estimated and results were compared with the classical ordinary kriging. And especially I want to ask something related with the undergraduate students, Yanis. The color, as you see at the left side, there is a iron grade color bar. Red means the highest values, while the blue one shows the lowest iron grades. And there is something we should be careful about, especially as SVM, support vector machines. And I'm just asking undergraduate students, what makes you feel uncomfortable with the SVM, which is located in here? I'm just expecting their comments. Yeah.
Okay, I'll just do it in Greek to
Okay.
Okay. Η ερώτηση που κάνει ο κύριος ATALAY είναι τι θα σας προβλημάτιζε στις εικόνες που βλέπετε, στα χρώματα που βλέπετε, την κατανομή τους, στην περίπτωση των support vector machines, τα SVMs που βλέπετε, σε σχέση με τις άλλες εικόνες που βλέπετε. Τα χρώματα είναι οι εκτιμήσεις που κάνουν τα διάφορα συστήματα, την περιεκτικότητα του σιδήρου σε ένα μοντέλο block. Ωραία. Και βλέπετε μια κατανομή αρκετά ανομοιόμορφη στις περιπτώσεις της 4, Kriging, νευρονικά δίκτυα, το XGBoost. Στο SVM τι παρατηρείτε? Σας το είπα ήδη δηλαδή κάπως. Και περισσότερο κόκκινο έχει και πιο ομοιόμορφη κατανομή τιμών. Έτσι δεν είναι? Well, it seems that there are two things that are kind of problematic. One is there's too much red. There's a lot of high-grade estimates there. The other is the overall spatial distribution of the estimates. They seem very smooth.
Smooth. Okay.
They are distributed more smoothly. There's not a lot of variance locally. We have big areas of orange. Of course, it's dependent on the legend as well, but it's very different to everything else. It's much smoother than all other types of estimates.
Okay, and thank you, our students participating the lecture and their comments. And I just want to share them that they are partially correct, I think. The high grades zone here is bigger, but it can be true. We don't know yet. But as you see in here, these high grade values are produced without any intersection with a drill hole, which is, I think, really dangerous because we don't have data, but we are claiming that this is a high grade zone. I think this is limitation of the support vector machines because in that part, it is clear that our trained model has to make an extrapolation because there is no data. What means extrapolation? It is out of the data domain. So it is extrapolated in high grades. But as an engineer, I never like such cases because you may make a mine plan by just relying on this block model. But in reality, if the grade is lower, it will change your mine plan. So when I see something like that, I advance with caution. So the main takeaway maybe from this example is that don't just rely on a single machine learning results. Compare it with different approach and be cautious about high grade place when it is extrapolating because we know very well that in today's technology, machine learning algorithms are not good in extrapolating. There are some attempts, but as far as I see, they are not good in extrapolating. But other approaches, except then support vector machines, I think they worked better because as you look the results, they created similar results. So I never recommend using SVM when we have to extrapolate. Okay, thank you again to our students. And I just want to share my thoughts with them. And the results showed us XGBoost was the better alternative. SVM just was a good fit, but as I said, it has some problems. Deep neural networks worked worst among them. Okay, I just stopped at whether your students are asking something or
No,
you are
sorry,
just.
Fırat, it was just
No, don't
a
worry.
continuation of the previous questions that I had to clarify something. I'm sorry for talking.
No, don't be sorry. I just
Uh,
like to
yeah.
involve every
So they asked
conversation. Yeah.
at the end of the day which one was more valid, and I just explained to them we
XGBoost
not.
was better.
Okay.
Yeah. As I said, extrapolation is a really risk that creates a risk. So practitioners should be careful about when they are extrapolating. And some people think that machine learning algorithms are not creating a smooth result, but it is not the case. They are also suffering from smoothing, like the classical querying. And these are the key insights or takeaways from this paper. And nearly 40 minutes passed since the beginning of the lecture. In Turkey, generally, we are giving a break, but it is up to you. Whenever you want, we
Okay.
can give break or continue.
Are we like halfway, Fırat, or
Nearly.
nearly?
Yeah,
Okay.
yeah.
Well, if it makes sense as far as the content as well to have a break now, we can have it now.
I
If
will continue with the great estimation. So I have two more case studies or
okay,
one. I'm not sure.
well,
Then after it will be better too, because we will just jump into the prospecting studies, which are not related with me
okay.
directly. Yeah.
But if the two studies are going to be quite some time, we can.
It will take nearly 10 or 15 minutes.
Okay.
Okay,
Okay.
yeah.
So let's
To
do them as well, and then we have.
continue. Okay,
Yeah.
thank you. And again, we are continuing with the mineral resource estimation. And in this work, I just want to assess the effect of domaining in mineral resource estimation with machine learning. It was an editor choice, like the SMA, because as you know very well, editor choice is something prestigious, and editors thinks that it will be important in the future, important study for the future, because it is still the first study that's assessed the effect of domain in research estimation. Because most people think that, or just advertising machine learning as an people saying that machine learning algorithms can learn from any data. But intuitively, I know that it is not true, and I want to prove that. As I said, it is the first study related with the domaining. And what is domaining? What is a domain, by the way? And as you know very well as an earth scientist, geological occurrence may occur in different conditions. So these different zones are considered as different domain because they are statistically different from the other zones. Like the case in here, for example, this is a copper example, which oxide zone is over the sulfide zone. And in this study, the boundary was very rigid. So you can clearly separate the zones from each other. And as written in here, domaining is the process of partitioning a deposit in homogeneous geological zones or domains to satisfy stationary assumption in geostatistics. And this study, as I said, assessed this approach. While this is standard practice in kriging, and as far as I see, in many mineral resource estimation studies related with machine learning are not employing the domaining. I couldn't see any study that employs the domain with machine learning, and I just want to test that whether domaining is important or not. I know the result intuitively, but I want to make an anecdotal work over this. As I said, most of the advertisers of the machine learning funds thinks that machine learning algorithms can learn from any data. But as we will see in a moment, it is not the case. And in the case study, the deposit was showing hard boundary, which means that low-grade and high-grade domains were separated nearly clearly. And again, I just want to test by using XGBoost, support vector regression, and ensemble learning approach in two scenarios. In the first scenario, I just try to use this technique without using a domaining approach. I used wool data in order to train the models. And in the second scenario, I just divided deposit into the domains and used this related data and trained this related data differently in these domains and estimated by using the training and compared the results. And critical finding was that if we don't use the domain, a smearing effects is observed, which means that high grade values are underestimated in the high grade zone, and the low grades were overestimated in the low grade zone, which are close to boundaries, which is we don't like in my planning exactly, because we just want to see the realistic block models in applications. And approximately 30% of the blocks in the high grade domain displayed values completely outside or their expected statistical range. They were below their minimum values of the composites. So results were horrible. And to sum up, when we don't use domaining, the results get worse. So unlike claimed or machine learning algorithms does not learns very well from data, even though I tried my best to train the models. And so I'm just only recommending to not use domaining when available data number of data is very low in the case of, for example, exploration. But when we have data, or when we want to make a or resource mineral resource or reserve estimation, just use the domain if there are more than one domains. And to sum up everything, these findings confirms that analogous to classical methods, domaining is essential for accurate mineral resource estimation using machine learning. So we shouldn't replace domaining even we are using a machine learning approach. And currently, even though the paper is relatively new, it's started to take citations from other works, and one of the citations I think summarized very well, and I'm taking I took this from the paper that cites my work, that says that currently anecdotal evidence, which is my work, would suggest that learning speed and convergence are less of an issue when compared with the accurate domaining. So it is also recommending to use domaining based on my works. And one last thing, Yannis, you know very well because we were at the same session. I just want to share it with your students and or colleagues in this course. And this is the first application of the graph attention networks. Again, I won't go in the details of the graph attentions. So, because if I try to explain all the methodologies, this course will take hours and hours. So I will generally focusing on the results. And as I said, this is the first application of graph attention networks. As you see at the right side of the presentation, composites are really similar to graph level approach. What graphs makes is that they just finds the topological relation between the data in order to create the model. And the nodes are really resembles the or composite. So I thought that I can use this approach in mineral resource estimation because, as you know very well, the methodologies of the machine learning are on the exploration level in mineral resource estimation yet. Most of the techniques are not even tried, and one of them was the graph attention networks. And there are two approaches in graph attention in order to find the neighboring data composites in that case. First one is key nearest neighbors, which means that fixed number of neighbors are used in estimation, and another one was the radius based, which means that fixed distance results and use all the data in that threshold. And this is the main approach, very similar to which I already covered. We have an input layer, we have a model, and later data is divided into the training, validation, and tests data, and results are estimated based on the trained model. And results show that a radius-based approach is better in terms of statistics, but again with a caution sign, because as you see, some approach created unrealistic results. So as I'm repeating, never rely on the models because they are sometimes creating unrealistic or unacceptable results. So every time the results should be assessed by a human being or some rules. I already covered the results, and nearly 55 minutes passed in order to gain attention. I think it will be a good idea to have a break, because right now I'm just passing to another subject.
Okay.
These are my networks.
We'll have a break now, Fırat, and then after the break and before your second part, maybe we'll have a Q&A, a short Q&A, just
Okay.
for the first part before we
Okay.
forget what we're
Okay.
discussing first hour.
Yeah.
Okay.
And
Okay.
how
So,
minutes will we?
10 minutes.
10 minutes.
So
Okay.
5 past, we begin again.
Okay. Thank you.
Okay. Okay. So
I'm just again showing my screen.
okay. Yeah. Just fresh off the press, as they say. Another question on chat from one of our students about the slide with the block models from the different methods. Which one you consider to be more representative of the true gray distribution? I think you already answered that.
Yeah, XGBoost, my favorite one right
Yeah.
now.
Okay.
And we will some contradictory results in the next slides made by others. And I just asked them the question, but they couldn't answer me very well. But XGBoost, I think, is the best alternative. Because some other research says the similar. And in competition and in the interpolation, XGBoosts are superior.
Okay.
It is the case in great estimation also, I think.
Mm-hmm.
And right now, I just want to share a recent study because, as I said at the first part, the applications of the machine learning are really evolving rapidly. And so these are just from the findings of a company named Esan Eczacıbaşı, which they are producing, which have a copper mine in Turkey and producing a copper. And their works are related with the 2D exploration targeting using the ensemble positive unlabeled data learning approach. As I said, it presented 1 week ago, so I just want to be up to date and just want to share with you. And one thing that I want to say that all shared information in here is already public. I am not sharing anything beyond the public because I'm working with too many companies, consultant of the companies and working with the governments also at the same time. All hidden things or secret things are not exposed here. So all the shared information is already public. You can find on internet maybe. And this, as I said, is work from the Eczacıbaşı workers. And they just try to use machine learning in mineral exploration. And as written in here, it is something like that, finding the needle in haystack without knowing where the hay ends. Mineral exploration is something like that. And in mineral exploration, as an earth scientist, we all know that mineralization is rare and leading to high imbalance data set, which means that we have some data in some features, but in other features, some data are missing, which means that it is imbalanced. And we have general lack of true negatives and bare results we have. So proposed solution by the Eczacıbaşı workers is that they just used bagging based positive unlabeled learning to handle this imbalanced and labeled certainty. As you mentioned, they used 50 layers, which are the features, and they have 3 layers of structural data, which consisting from faults and dikes. And they have 2 layers related with the geophysics, magnetic and gravity data. As written in here, which makes the 56 evidential maps used in the study. The study area was in Kazakhstan, Aktobe, but the company is a Turkish company. And they utilized hybrid machine learning frameworks. And first one they utilized is bagging PU learning, as I mentioned. They used ensemble learning, and they have 500 base learners. And they also employed the balanced random forest, which means that why they used balanced approach, because the data was unbalanced, so they have to use or utilize the balanced random forest approach. And their results shows that balanced random forest showed the best performance among the alternatives in terms of test recall and correct test predictions. So they thought that, sorry for missing prospective mapping, they just thought that their approach is balanced, robust, which means that they are highly effective for positive unlabeled learning scenarios. They just decrease the size of the prospecting area by using this machine learning model. And as you see, the BRF approach at the leftmost created the last target areas, and they didn't share all information or results with us, but they say that the target area shown by the BRF approach helped them a lot. So it seems that, or we have other works all around the world shows that machine learning is applicable tool in prospecting, like the case in here, because this is the third applications of the machine learning in Türkiye. So I just share example from Türkiye. That was related with prospecting. Right now, I just want to share a work of my friends from Hacettepe University again, but I haven't involved in this study. The study was related with the marble and prediction of monowire cutting machine performance parameter using artificial neural network and regression models. I just want to share with you the results because artificial neural network was used, but it is not a new study. It is published in 2018. As I said, all shared information already public. And I asked my friends to whether I can share with you or not. They gave me a verbal permission. Marble industry is very big in Turkey, and I think Greece is rich in marbles, and Italy is rich in marble. And even just marble export of Turkey is $5 billion. So I think makes the industry important for us, for Turkey. And in this study, my colleagues just try to accurately predict the unit wear and unit energy by using some inputs that I will cover in a moment. And at the right side, you can see a monowire located at Hacettepe University. And they used 8 different natural stones, 2 marbles and 2 limestones from Turkey, including Afyon White, Mura Pearl, Burdur Beige, and etc. They used these equipments shown in here. It's computer controlled, fully automatic monowire block cutting machine, and equipped with load cells, vibration meters, and power analyzer. And they made 240 cutting experiments with varying cutting speeds from 10 to 20 millimeters per minute and peripheral speeds in meter per second. And as an input, they used uniaxial compressive strength of the rock or marble or limestones, and cutting speeds and peripheral speeds in order to predict the unit energy and unit wear. And they compared results with multiple and nonlinear regressions. They found an exponential relationship in terms of correlations, which is higher than 0.7, which means that there is a linear relation between the results. And final output of this study is that artificial neural networks was the best performer. But as you see, they haven't used XGBoost or something like, because XGBoost was not discovered at that time, or methodology was not available. So they have to compare with classical methods, but they are claiming that artificial neural network is superior to other alternatives. It is, I think, expected results, because artificial neural networks, as you know very well, can capture high complexity nonlinear relationships. So I think it was expected. As I said previously, key takeaways of this study is that ANN is superior. They say that it's a practical tool. That you don't have to have a complex software, because some softwares are really expensive and some companies cannot afford to buy, especially in marble case, because in Turkey some marble companies are really small and their budgets are limited, so they may not have a budget for complicated software. So this may be alternative to softwares, commercial softwares. And other thing that I want to share with you from the Akasya mine, this is also another company in Turkey, and the biggest open pit copper producer. Şahin and Doğan are working at there as an engineer, and their works are related with the mineral processing. As written in here, AI-based comparative analysis of machine learning models, optimizing grinding circuit performance in copper ore processing. Again, this was presented in IMSET 1 week, in last week, sorry. Again, I just want to share that all shared information is already public, so I can share with you. This is relatively new work, and the challenge was ore grinding is one of the most energy-intensive stage in mineral processing. I think it is known very well. And one thing I want to ask you, Yannis, is in Turkey, we are just teaching mining and mineral processing at the same time at undergraduate level. Is that the case in your country?
Yes, it is, but
Hmm.
they won't be in the same year.
Hmm.
It's a 5-year course, our mineral resource engineering course, and they will do surface and underground mining on the 3rd year. And then mineral processing will be in the 4th year, I think. Εμπλουτισμός.
Okay.
Εδώ μόνο. Το έκτο είναι. Στο έκτο είναι υπόγεια και στο έκτο είναι και εμπλουτισμός. No. I've been corrected. They're in the same year. So
Yeah, okay, very good.
yeah.
Because in some countries, they are not teaching about mineral processing, and the chemists are dominating the area. But in Turkey it is similar. We are just starting to teach mineral processing and mining from the 2nd semester of the 2nd year.
Yeah,
And it goes until the end. Yeah, similar. It is good because as a mining engineers, we should not leave this area to other occupations.
Yeah.
It is our job because without mining knowledge, we cannot establish the link from mine to mill. We cannot create this chain. I think the chemists will not be able to understand all aspects of mining, so their addendum to our creation of value level might be less than a mining engineer. So I think it is the best approach. So yeah. Okay, and to continue, conventional control strategy relies on fixed set points, often fail to capture complex and non-linear relationship, as written in here. They just try to use AI solution in here. They just thought that they might accurately predict the product size in order to increase efficiency and operation stability. And at the right side of the presentation, you can see that their flow of the process. They are using SAG mills, ball mills, and pebble mills in order to decrease the size, and hydrocyclone to separate based on the size, and then sending the output of the hydrocyclone to the flotation. And I don't want to read the process flow, as you can see very clearly. And I'm not expert in processing also, but I just want to share you their results. And as I said, data was collected from Acacia mine operation in Turkey, which is already public. And as I said previously, machine learnings are data hungry, so they have used 750 samples and collected from SCADA system. Their features were feed rate, mill power, cyclone pressure, load ratio, and pulp density. And they had to create synthetic data because their data were imbalanced. So by using real data, they created synthetic data. And you can see the impact analysis. They claim that random forest creates the best results. And I just asked them question, I was expecting XGBoost to perform best. They couldn't explain to me why random forests worked better, because the main problem in machine learning algorithms that their explainability. You cannot comment on the result. They are just giving you the results as is. But they have made some attempt to find the best or most important feature. And in that case, it was the feed rate. And as I said, they tried the tree-based ensembles of deep learning, LSTM and XGBoost. And they are claiming that model accuracy is highest at random forest. But theoretically, I know that XGBoost should perform better because it is specialized version of the random forest. So I think results, I'm sure that results are correct, but we cannot explain why this happened. And the prediction accuracy, it seems like that random forests is really high compared to actual PAT values. And XGBoost showed moderate deviation, and LSTMs exhibits large scatter in the specific data set. I think it is important because it is hard to generalize the findings, as they say it in here. It is specific to data set. That might be the main problem of any machine learning, because transfer learning may not apply every time. So you have to retrain your model for every given data set. Sometimes transfer learning may create a value, but it is unclear that in which situation it works better. And I already said this. They are claiming that tree-based models are superior. And one thing they are saying that the high accuracy suggests this model can serve as soft sensors, providing real-time feedback, which is, I think, really important, where sensors are unavailable or expensive. So it decreases the costs, I think, which is really important. And another thing I want to share with you, that this is the feature works with the previous study, but I don't want to go in detail. Smart imaging analysis of flotation frauds using artificial intelligence technique for process optimization. A study based on the Demir Export company, which creating a coal or some metals in Turkey, very big company. And Harzanak is also my friend, has a PhD from Hacettepe University. And Çınar is a lead data scientist at the company. They just monitor the frauds. I think everyone in this room knows the importance of the frauds in flotation, because the main mechanism is related with the fraughting. And the main challenge with the frauds is that frauds are dynamic and short-lived. And you cannot manually observe them every time. So they just try to create a machine learning algorithm that follows all the frauds and mimics the behavior of the human beings. And they just used advanced image techniques and used AI analysis and process control in order to follow the frauds. And the most important part is that you have to take a good picture of the photo of the frauds. So you have to illuminate, and they just create some LED configurations as shown at the right side of the presentation. And they select the camera which is appropriate for the job. and they have created a custom stand like to shown in here. And the main problem was the durability. So they overcome, and in this data set, which is the example is given as a supervised learning example because they are just marked some parts of the frauds as a supervisor. So they had to label them. And they had to segment the image as seen at the right side because some bubbles were touching each other and they want to find the bubble areas. They want to accurately count two bubbles, and also the shape of the bubbles are really important. So they managed to utilize instant segmentation, 20 frames per second was used. And they managed the dynamic analyze by optical flow. They just finding the velocity and the speed at which the frog moves towards the launder, as you see at the left side of the presentation. They managed to find the direction of the flow and the stability of the bubbles. And later they made color and surface analyze using RGB analyze, size calculation, and process correlations. And they created a holistic system. And they are claiming that they can live monitor the process. So they are working over the subjects. It is not finalized yet, but their primary results are very well. They have reached their claims. And that is the end the applications of AI and machine learning in Turkey. There are too many examples, but I just want to share the most recent and most important one in the limited time because we have a limited time. As I said many times, it is evolving and rapidly everything changing. So I just want to share the latest developments in Turkey most of the time. Right now I have a few slides remaining. It is related with the future expectations in the world. Again, it is mining specific. I don't want to extend too much about the future expectations because I believe that most of the future expectations are wrong. So because nobody can know that what company or which company or which scientists are about to discover in their laboratory. But there are some clues, I think, related with the machine learning and AI. First one is, I think everyone in this room knows very well that deep sea mining systems are one, I think, one thing that might be realized in near future. And other one is the space mining, because without artificial intelligence or machine learning, these concepts will not be realized because the environment is really hard at that places, and we cannot send humans to that places. So we need some kind of approach that mimics the behavior of the humans. So AI is the best alternative or the best approach in that kind of hard environments. And as you know, the population of the world is increasing, and the pace of the increasing is not slowing. So whenever population increase, metals or raw material demand to metals or raw materials increases. So we need more metals, more raw materials. So we have to more mice in future, but as too many experts in this room know very well, we have more mice. So we have to look to alternatives like the seas and space. But when talking about this subject, it is really easy to get into trap of getting unrealistic results. So in order to avoid this, I just really like the idea of technology readiness level. So I want to discuss about that. It is created by NASA as far as I know. So I just put the reference below the reasons. I'm not producer of this system. As I said, NASA is created this approach. So I'm not claiming the intellectual property of the figure and the explanations. So the technology readiness levels are the type of measurement system used to assess the maturity level of a particular technology. Each technology project is evaluated against the parameters for each technology level, and then it is assigned to a TRL rating based on project progress. There are 9 technology readiness level. TRL 1 is the lowest and TRL 9 is the highest. So we can split these levels in 3 categories, I think. First one starts from 1 and ends at 3, which is generally at conceptual levels. And the second stage starts from 4 and ends at 6. This is the development part, I think, and the rest of the TRL levels are the deployment levels. For example, at that levels, you have prototypes, working prototypes, and it is nearly ready to be commercialized. So I just want to assess the space mining and deep sea mining from that viewpoint. And I think at deep sea mining, we are at the 3 to 5 TRL level. I'm not sure, so I just want to be fuzzy about that. So because, as you know, there are some prototypes that can excavate the deep sea nodules, especially named one example in here, Apollo 2. That is working prototype, but I don't think that it is going below the level 5, because in order to have working system, we need to have too many other components to get these nodes from deep sea to surface. But again, I'm thinking that we have some working prototypes, but we couldn't create the value chain right now. And also, I know a company that was non-profitable, so the company was closed related to deep sea mining. So the commercial applications of the deep sea minings are not seen at the industry. And from space mining, as everyone knows very well, some asteroids are really valuable. They contain really valuable metals. So too many governments or companies are trying or thinking to, get these values, and like the case in moon, because as no one at the dark side of the, at the south pole of the moon, there are too many heavy rare earth metals, and China is right now dominating the rare earth market. So some other countries are looking to whether they can get this heavy rare earths, especially from the moon, and produce, but it is right now at conceptual level. So the TRL level is between 1 and 3. It seems like futuristic, but with developing technology, I think we will be able to produce some rare earths or other, so maybe metals from the moon. But most nearest candidates, or nearest candidates, sorry, are the rare earths, heavy rare earths. And this finalized my presentation, and nearly 2 hours passed. And if you have any questions, please don't hesitate to ask.
Yeah, that was great, Fırat. Thank you very much.
I'm stopping the share, so in order to
Yes,
see you
and we
better.
can stop the recording as well.